The probability of compound events. Objective of this lesson to find the probability of mutually exclusive events or inclusive events. Before we take a look at those definitions, let's take a look at this example. Suppose you're playing a board game with 3 friends, and this is a game of Monopoly. It's your turn and you need to roll a 6 or a 10 to avoid landing on properties owned by the other players and having to pay them rent. What is the probability that you can avoid paying rent? Okay. The chart on the right is a partial list of two sums when two dice are rolled. Copy and complete the chart, and these are your directions. Circle the combinations with a sum of 6. Okay, and another one, circle those with a sum of 10 using a second color. Okay, so if you copy this chart on graph paper, and on the vertical side, the vertical numbers the vertical axis will be for the first die. The horizontal axis on top will be for the second die. And if you notice, if I roll a 1 on the first die, 1 on the second die, the sum would be 2. Okay? So if I roll a 3 on the first die and a 2 on the second die, the sum would be 5. Okay? And so on and so forth. This is how it works. So it says there, circle the combinations with a sum of 6 with a colored pencil. So sum of 6 will be these. That's 1. 2 plus 4 will be 6 too. 3 plus 3 will be 6. 4 plus 2 will be 6. And 1 plus 5 would be 6. So there are 5 possible combinations out of 36. Okay, and then circle those with a sum of 10. Sum of 10 would be 6 plus 4 is 10. 5 plus 5 is 10. And 6 plus 4 is 10. So those are the directions that were asked of us. Finally, all we need to do is fill in the rest of the chart. And these are the sums of the cancel that, baby. Okay, these are the sums of the two dice. Okay, and there are 36 possible combinations, wherein 5 of those combinations are have a sum of 6, and 3 of those combinations have a sum of 10. Let's answer these questions then. What is the probability that the sum of the dice will be 6? Okay, since there are 5 of them, okay, it'll be 5 out of 36. What is the probability that the sum of the dice will be 10? Since there are 3 tens out of 36, it'll be 1 out of 12. Why is it 1 out of 12? Because you have 3 over 36, and the simplest form is 1 out of 12. Okay? What is the probability that the sum of the dice will be 6 or 10? All we need to do is count that 1, 2, 3, 4, 5, 6, 7, 8. That'll be 8 out of 36. Okay? And if you put it in simplest form, it would be 2 over 9. Okay? And what do you notice about the probabilities of A, B, and C? Well, if you notice, if I add 5 out of 36 plus 3 out of 36, okay, if I get 5 out of 36, and I add 8 out of 36, okay, sorry, not 8 out of 36, but if I add 3 out of 36, right here, the sum would be 8 out of 36. So, what do you notice about the probabilities of parts A, B, and C? You would notice that the sum of the probabilities of pairs A and B equals the probability in part C. And this is where we start off with our lesson. When two events cannot happen at the same time, like rolling a 6 or a 10, they are said to be mutually exclusive. The probability that two mutually exclusive events will occur is the sum of their individual probabilities. Again, let me repeat that. When you say mutually exclusive, they cannot happen at the same time. Let me give you another real-life example of mutually exclusive events. Mutually exclusive events is like when you are sleeping and eating. Those are mutually exclusive because they cannot happen at the same time. In this case, rolling a 6 or a 10 from a pair of dice is mutually exclusive because they cannot happen at the same time as well. Okay, so we simply add their probabilities. The probability of A or B happening in mutually exclusive events is simply the probability of A plus the probability of B. Let's take a look at this example and see how this works. You have the spinner at the right is spun. What is the probability that the spinner will stop on yellow or A2? Yellow or A2. Since 2 is neither yellow and the yellow does not have a 2, these are mutually exclusive events. They cannot happen at the same time. Okay? So, what do we do? The probability of yellow or a 2 is equal to the probability of getting a yellow plus probability of getting a 2. And the probability of getting a yellow is 1/3 because there are 2 of them out of 6 possible outcomes. Simplest form is 1/3. Probability of 2 is 1/6 because there's 1, 2 out of 6. And if you add 1/3 plus 6, I would probably do this. Instead of simplifying it first, I would put 2/6 plus 1/6. Sorry, not 7. I'm thinking of the answer already. Okay, 2/6 plus 1/6 will give you, that's not the answer anyway, 3/6 or 1/2. Okay, so the probability that the spinner stops on yellow or a 2 is 1/2 or 50%. Now, when two events are inclusive, they can happen at the same time. Okay, so we talked about exclusive events, events that cannot happen at the same time. So, but when you talk about inclusive events, these are two events that can happen at the same time. For example, from a standard deck of 52 playing cards, it is possible to draw a card that is both a queen and a red card. They can happen at the same time because it can be a queen and a red card, a diamond card, or a hearts card. What is the probability of drawing a queen or a red card? Okay, so we take a look at this. The probability of drawing a queen is 4 out of 52 because there are 4 queens in a deck of 52 cards, 1 queen in each suit. And then the probability of drawing a red card is 26 out of 52 because there are 26 red cards, 13 plus 13 out of 52, 13 hearts and 13 diamonds. And the probability of therefore drawing a red queen will be 2 out of 52 because there's only 2 queens that are red out of 52. So, queen of hearts, queen of diamonds, that's what you have. What do you notice about this particular thing that we did here? Okay, the probability of drawing a red queen is counted twice, once for the queen and once for the red card. We talked about that. To find the correct probability, you must subtract the probability of a red queen from the sum of the probability of a queen and of the probability of the red card. So the probability of drawing a queen or a red card will be 4 out of 52 plus 26 out of 52, and then you subtract the probability of a red queen, which is 2 out of 52 or 7 out of 13. The probability of drawing a queen, okay, or a red card will be 7 out of 13. So get the probability of getting a red queen, get the probability of get the probability of getting a queen, add the probability of getting all red cards, and then subtract the probability of drawing a red and a queen. So you add that, you subtract that, you end up with the probability of a queen, okay, or a red card. Okay, and brings us to the probability of inclusive events. The probability of one or the other of two inclusive events can be found by adding the probability of the first event to the probability of the second event and subtracting the probability of both events happening. And that's exactly what we did in that example. So the probability of A in symbols, or B, is equal to the probability of A plus the probability of B minus the probability of A and B happening. Okay, let's take a look at this example because this will make it more concrete for you. An auto dealer finds that of the cars coming in for service, 70% need a tune-up, 50% need a new air filter and 35% need both. What is the probability that the car brought in for service needs either a tune-up or a new air filter? Remember, this is a good example of an inclusive event because both of these things can happen at the same time. A car can come in with a tune-up needing a new air filter. So since it is possible to get a tune-up and a new air filter, these events are inclusive. So the probability of getting a tune-up is 70%, which is 70 out of 100. The probability of getting an air filter is 50% or 50 out of 100. Okay, and the probability of both of them would be 35 out of 100, tune-up in an air filter. So just like what we did, we get the probability of A plus the probability of B, subtract the probability of both A and B happening at the same time. So in this case, 70% would be your tune-up, 70 out of 100, plus 50 out of 100, the probability of getting a filter, subtract the probability of getting a tune-up and an air filter, which will give you 85%. So the probability that the car needs a tune-up or an air filter is 85%. Okay? Lessons done. On Google Forms, type a summary of what you've learned responding to the objective of the lesson. Type a question you might want to ask in class. Thank you.